This project runs on LibGDX with Kryonet on the client side, and for the server I use Spring Boot with MySQL and Liquibase. The server is deployed with Docker, automated by Gitea CI and monitored with Grafana. Let's look first at the client structure. As you can see, there is not just client and server, there is also a submodule named common. This is code shared by both server and client, and not just for DTOs. This submodule actually has all the gameplay code. But why? The client itself is just a renderer. The game screen does not know anything about gameplay. It just receives a list of step-by-step instructions like card summon to slot, spell cast, card attacks, card death, etc., and renders them in order. The entire gameplay logic lives in the common submodule. This way, client single-player and server multiplayer run the same code for game simulation, and the client's game screen doesn't need to know the difference between online and local play. I just need two match client implementations. The first one creates a match. It is a top-level class containing the game logic, the same class that runs on the server, and talks to it directly by calling public methods. The second talks over TCP to the server and gets a list of instructions for the renderer from the network. You can see here that I even use same class for receiving those rendering command lists for the game screen. This match action controller has two methods. One, when packet arrives from TCP, second, when packets got from local event bus. If we look at the server code, exactly the same thing happens. Data is packaged into packets and sent over TCP to clients. The client connects to a Spring Boot server that consists of several main parts. Player storage stores all connected players and their state. This service also has its own thread that periodically cleans up players who disconnected some time ago. Game storage holds all current game metadata and runs their actual simulation. It cleans up finished games and passes results to other services that update user info, game history, ratings, etc. Matchmaking service runs in a separate thread and periodically checks if any players are currently searching for a game, pairs them together, creates a game and sends the new match info back to the players. This service creates an instance of the same match class used by single player, wraps it in a server-only game class, which has all the game data important for the server, and pushes it to game storage. When a player taps search, the client sends a matchmaking request packet over TCP. The server receives it, queues the player, and when a match is found, metadata about the new match is sent back to both players. From there, each player's decision, summon a card, skip the turn, or leave the game, is sent to the server. No UDP, everything is TCP. Since this is a turn-based game and we don't need to send many packets fast, TCP is a good fit. All data is stored in MySQL. This could be any other relational database. I just already had it on my VPS. With Spring, I like to use Spring JDBC data library. I like how little database code you need to write with it. Liquibase is used to keep a consistent database schema across all servers, dev and prod in my case, and to avoid manual changes to database tables. If I need to change the schema or do some data migration, I just write a Liquibase migration script, and on the next server restart it applies those changes automatically. I also mentioned Grafana. Here's how I use it to monitor the server. This is a screenshot from my development environment. Micrometer exposes metrics via Spring Actuator, Prometheus scrapes them, and Grafana visualizes them. I track online players, active games, and error rates. Adding new data tracking with Micrometer is pretty easy. You just register a counter, gauge, or timer. All these parts except the client, of course, are deployed with Docker. I use Gitea workflows for automated Docker image builds. Those images are uploaded to a private Docker registry, and on the remote server, a watchtower container periodically looks for new versions and updates the game server. Android releases are also automated with Fastlane. I run one command and the app builds, signs, and gets pushed to all stores, creating a test release with all metadata, patch notes, and screenshots. I just need to promote the version to production in each store's console after review. That's the big picture. LibGDX and Kryonet on the client, Spring Boot and MySQL on the backend, Docker auto-deploy and Grafana monitoring. If you want the full deep dive into the CI/CD pipeline for the server and Android with Fastlane versioning and multi-store publishing, drop a comment below. If there's enough interest, I'll make a dedicated video. Check out Astral Tournament on Google Play, link in the description. Thanks for watching.